Hello everyone. Let's get into understanding this introductory topic to hypothesis testing. What we have gone about with seeing in the subject of quantitative techniques, if you recollect, you have studied about what is research, what are types of research. You have got to understand what is probability and probability distributions. After that, let's look into what is this hypothesis testing all about in research. What are the types of hypothesis? What do you mean by type 1 and type 2 error? What is the process that is involved in hypothesis testing? Now, this is an introductory lesson on what is hypothesis testing. Now, this forms a foundation for the other units that are there in block 4 as well as an unit in block 5 which is to do with statistical quality control charts. Now, if you recollect what we do in research, there are 4 stages basically. It could be summed up with whatever you have studied in block 1. It's to do with research has got 4 phases, that is to do with observation, hypothesis, experimentation and conclusion. Observation, if you go about with looking at, it is through our 5 sense organs we receive the stimuli, we process it in our mind and we attach meaning to it. The meaning we attach could be right or wrong. Now this is what we call it as the hypothesis. Thesis is final, hypo is tentative, hypo is temporary. So whatever we go about with our understanding, the statement which we make, we have to go about with conducting an experiment and figure out whether we accept or reject our statement. And from the conclusion that we draw, somebody notices something and the cycle of research goes about with continuing. Now, if we go about with studying the entire population, talk about one individual, we call it the deductive process, that is going from general to particular. Now, if we study about a few individuals and whatever results we get, we say it holds good for the entire population. This is what we call it as the induction study. So it's important for us to understand the words called population and sample. Now, what includes all the measurements put together is what we call it as a population, and a part of the population is what we call it as a sample. Now, what is hypothesis? So as I've said, in simple words, hypothesis is an educated guess. It is a prediction about what you think might happen in a particular situation. It's a statement that can be tested to see if it is true or false. There can be various types of hypotheses. Let's say in science, we have all learned that if plants are exposed to sunlight, the plants grow. If they're not exposed, it doesn't grow. So this is an hypothesis. Suppose somebody is suffering with an ailment of common cold, then taking vitamin C supplements would go about with reducing the duration of common cold. In psychology, it is always said that if somebody gets adequate rest of 8 hours, he would perform better. Or in business, if we say that if we offer a discount of 10% on products, it will increase the sales by 20%. Now, reducing plastic, which is non-biodegradable, will decrease the pollution levels in the ocean. Now, students who study with flashcards score higher in tests than those who do not. Now, this is something to do with hypothesis in education. Suppose in social hypothesis, we say individuals who participate in community service like NSS and other things there are more likely to be satisfied with their lives than those who do not. And what we talk about hypothesis is it's a statistical method that helps in making decisions or inferences about population parameter based on sample data. So it involves formulating a hypothesis and using sample data to determine the likelihood that this hypothesis is true. So we got to understand 2 technical terms. One is parameter and one is statistic. Now, what is this parameter? Things which can be measured and expressed in terms of numbers is called as a parameter, or population related details are called parameter. Sample related details are called statistic. What details are these? It could be mean, it could be size, it could be standard deviation, or it could be proportion. So for the best knowledge that we have to apply for this block there, you got to get acquainted with a few symbols or notations. For mean, for a sample, we use a notation x bar, and for population, we use a symbol mu. Standard deviation, which is deviation from the mean, For population, we use a symbol sigma, and for sample, we don't use the word standard deviation. Instead, we call it standard error, and we use the symbol S for it. Proportion, for population, we use a symbol P, and for sample, we use a symbol P bar. For size, for population, we use a notation capital N, and for sample, we use a simple small n. Now, let's understand what is this central limit theorem. You got to recall what you have studied in block 3. After probability, you studied probability distributions. And in that, if you go about with noticing, you have studied the binomial distribution, the Poisson distribution, and the normal distribution. So, the normal distribution normally talks about the symmetry, a bell-shaped curve, which is something which is very useful. So, in central limit theorem, we say when you take a large number of random samples from a population, the distribution of the sample will approximately be that of a normal curve. So, you understand what is standard normal curve. We say a standard normal curve is a normal curve with zero mean and unit standard deviation. So, we talk about 3 sigma limits. Now, you recollect the formula that you use for normal distribution for calculating the z value. You say it is x bar minus mu is divided by sigma is equal to z. Now, z indicates the area between a particular point along a standard normal curve and the mean of the standard normal curve. Now, hypothesis can be categorized into various types. The first one is to do with null hypothesis, which is denoted by the symbol HO, which is a statement of no effect, no difference. It is more about indicating what is a status quo. It is an hypothesis that researchers typically try to disprove. For example, let's have a null hypothesis that there is no difference in the average scores of students taught by 2 different methods. It could be a physical method or it could be an online method. Now, alternate hypothesis is the other one where we talk about H1 or HA, which represents a statement indicating presence or of an effect or a difference. It is what the researchers wants to prove. Continuing from the null hypothesis, we say HA here is there is a difference in the average score of students who are taught by 2 different methods, that is the physical and the online method. Now, let's understand 2 more things. This is important where we talk about the non-directional hypothesis and the directional hypothesis. Now, the non-direction is the hypothesis is using a neutral word. Suppose you want to test whether there is difference or not. We are not sure whether it is high or low. We only talk about the word difference. Let us say there is difference in the test scores between students who study different amounts of time. Then we call it as a two-tailed test, wherein the rejection region is there on both the sides of the normal curve. That is the right side and the left side. Now, the directional hypothesis, we are very clear about the kind of word that we use, whether it is a positive connoting word or a negative connoting word. So, it indicates the direction of the expected difference or relationship. So, students who study for more hours score high marks. This is indicating a positive connoting word. So, we use a right tail test, which is a one-tailed test. Now, students who study for less hours will score low on the test, which is a one-tailed test, which is a left-tailed test. So, we indicate the rejection region in the right side, which is a right-tailed test. We indicate the rejection region on the left side of the normal curve, which we call it as a left-tail test. Now, hypothesis testing, we try to interpret or draw conclusions about the population using sample data. So, hypothesis test evaluates 2 mutually exclusive statements about a population to determine which statement is best supported by the sample data that we have selected. So, when we use the word mutually exclusive, what do we mean by that? That is, if we select the null hypothesis, we are not accepting the alternate. When we reject the null, we are accepting the alternate hypothesis. So, the general goal of hypothesis test is to rule out a chance or explanation for the results from a research study there. So, hypothesis testing is a technique to help determine whether a specific treatment has an effect on an individual belonging to a particular population. Now, it's very important that we understand what is a type 1 error and what is type 2 error, because in hypothesis testing, this determines the level of significance. Now, we said hypothesis is a temporary or a tentative statement. It is our understanding. It is a hunch. It is an educated guess. So, the guess that we made could be true or false. In the end of the hypothesis testing, we may accept or reject this temporary statement. If the statement is true and we tend to reject it, we call it the type 1 error, which is denoted by the Greek letter alpha. If the statement is false and we go about with accepting it, we call it the type 2 error, denoted by the Greek letter beta. So, to put it in simple words, what is type 1 error? If the hypothesis is true and we reject it, we call it the type 1 error. It is also equivalent to false positive, and this is what we take it as the level of significance. And type 2 error is when the hypothesis being false and we accept it, and this creates what is called as false negative. Now, what is this level of significance? So, normally we denote this type 1 error with a Greek notation alpha, and it's the maximum probability that we have. So, for a confidence level of 95%, the level of alpha is 0.05. What does that mean? This means that there is a 5% probability that we will reject a true null hypothesis. So, hypothesis testing process, we state what is the research question, we specify the null and alternate hypothesis, we calculate the test statistic, we compute the probability of test statistic, and we state the conclusions. So, what do we mean by level of significance again? So, it is to do with the chances of committing a type 1 error, that is rejecting a true null hypothesis. So, in simpler terms, it is the probability of concluding that there is an effect or difference when there is none. Now, there are some key points that we have to look for what is the level of significance. If you are attempting it in the exam or trying to understand it for Z-test, T-test, chi-square, ANOVA, if nothing is mentioned, we take it as a norm 5%. If the question paper setter is very specific, whether it is 5%, 1%, we go by the way it has been denoted in the question. And what is important about the level of significance is it controls the rate of false positives in statistical testing. It provides a standard of making objective decisions about whether the observed effects are likely due to chance or represent a true effect. Now, what is parametric and non-parametric test? A little while ago we said things related with the population is called parameter, things related with the sample is called statistic. Now, what do we do in parametric test is, if we know everything about the parent population, if we draw a sample about a parent population, on this if we apply statistical tools or hypothesis testing, we call it the parametric test. Now, if we have a sample and we are not sure about to which parent population this sample belongs to, and on such a sample, if we apply statistical tools, we call it the non-parametric test. Once again, if we are aware of the parent population characteristics and a sample drawn from such a population, we apply statistical tools, it is called parametric tests. And we have a sample, we are not sure about the parent population characteristics, we call it the non-parametric tests. So, parametric tests assume the underlying data about the specific distribution, and we know about the parent population characteristics. So, some of the common tests that we do in the parametric test are Z-test, which we call it as the large sample. We have it in the following units in this block, where the sample size is more than 30, and we assume that it is drawn from a population which has got characteristics of a normal distribution. T-test, we call it as a small sample test, where the sample size varies anywhere between 1 to 29, and it is called as a small test. So, when we compare more than 2 sample means, we call it for ANOVA or analysis of variance. There could be Pearson correlation, regression related analysis. These are some of the examples of parametric tests. Now, non-parametric, as we said, it does not assume any specific distribution. That is, we are not sure whether the parent population has got normal distribution or not. and we don't know anything about the parent population size or standard error or standard deviation or in terms of proportion and other things there we apply the non-parametric test. And common among them, if you look at, is to do with the chi-square test and other things. So typically what we do in hypothesis is we frame the null and alternate, and we go about with trying to check based on a parametric or a non-parametric test. So we have the parametric and the non-parametric. And again, to reiterate, what is this one-tailed versus two-tailed? Statistical tests can be directional. So that is where we have the one tail. It means the alternate hypothesis is proposed either as an increase or decrease of result. In an example, we wanted to test if customers increased. So it is a case of one-tailed test. So here we have a confidence of 95% or 5% of the probability distribution is in the direction of testing right side. Suppose we say the word increase is a positive connoting word. We have the rejection region on the right side of the normal distribution curve. So this is typically a normal distribution. So we talk about a two-tailed test where we have the rejection region on two sides. So for 5%, the 5% get distributed as 2.5 on the right side and 2.5 on the left side. And Z value is 1.96, which is based on the normal distribution. Now look at this. When we talk about one-tailed test, it could be a left-tailed test. Look at it. The alternate hypothesis has got a less than symbol. If it is a right-tailed test, we use the symbol which is greater than. And if it is a two-tailed test, we have for alternate hypothesis a symbol of not equal to. Now this is another thing which goes about with depicting what is right tail, left tail and two-tailed test. So in a two-tailed test, we have the rejection region on either side. In one-tailed test, the entire alpha value is represented on only either the right side or the left side of the normal distribution curve. So first things first, what we do in a normal distribution, in a hypothesis testing is we state the hypothesis. That is the null hypothesis. We say there is no effect, no difference, no relationship. It serves as a starting point that about the observed effect, is it due to a random chance? So we go about with saying that null hypothesis is the value is equal to 50 or not equal to 50 is the alternate hypothesis. So alternate hypothesis is a statement that contradicts the null hypothesis, and it represents what the researcher wants to prove. And here we say mu is not equal to 50, considering that it is a two-tailed test. Now we choose a confidence level or the significance value which is based on alpha. So as I said, we normally take 5% unless and until it is mentioned in the question to check it on 1%. So what is this 1%, 5% again indicate is the chances of committing a type 1 error, that is the hypothesis being right and we reject it. So if we say 5%, the chances of not committing a type 1 error is 95%. And when we say 1%, the chances of not committing a type 1 error is 99% times. And we have to select an appropriate test statistic. So as I said, based on whether we know the parent population characteristics, we decide whether it is a parametric test or a non-parametric test, whether it is large sample, small sample. Simultaneously, we want to check two variables or more than two. That is what we look in z-test, t-test and chi-square. So we determine a decision rule. What does this decision rule determine is, when we said that value of 1.96, that is a critical value. If it is a t distribution, we talk about degrees of freedom. Based on that, we have a table value which is there at the end of your reading material if you could go through, based on the alpha value that we go about. If the calculated value based on the formula is greater than the critical value, it falls in the rejection region and we say the null hypothesis gets rejected. Suppose the calculated value is less than the critical value, it falls in the acceptance region. We say the null hypothesis is accepted. So this is what is the decision rule that we go about with determining based on the critical value, and we reject and accept the null hypothesis. So we collect and analyze data and we calculate the test statistic by using the appropriate formula. Remember, whether it is z-test, whether it is t-test, whether it is chi-square, whether it is ANOVA, the steps of hypothesis testing remain the same. That is setting up of hypothesis, level of significance and critical value, the test statistic, the calculation and the decision part of it. and we would work out a lot of examples. Ultimately, it is a decision whether we accept or reject the null hypothesis. When we are accepting the null hypothesis, we don't talk anything about the alternate, but when we reject a null hypothesis, we surely claim as to what the alternate is all about. And we draw a conclusion. So if the null hypothesis is rejected, we conclude that there is sufficient evidence to support the alternate hypothesis. If the null hypothesis is not rejected, we conclude that there is not enough evidence to support the alternate hypothesis. So let's take an example very quickly. A company claims that on an average, the life of a light bulb is 1000 hours. Now, a sample was drawn from a LAL manufacturing unit. They drew 30 bulbs on an average life of 950 hours, and the standard deviation of 100 hours. The null hypothesis is the average or the mean is 1000 hours. The alternate hypothesis is not equal to 1000 hours. Now, the alpha is we take 5%, that is level of significance or chances of committing a type 1 error, or what we said, the hypothesis being true, and we go about with rejecting it. Now, the sample size is 30. Anything more than 30 is z-test. Let's apply a t-test. Anything to do with 1 to 29 is a t-test. So we do a two-tailed test. We said it is not equal to the symbol. So it could be more than 1000 or less than 1000. That is how we look at it. And we get an answer. So degrees of freedom for 29, when we go about, degrees of freedom is 1 less than the sample size. So out of 30, when we deduct 1, it is 29. So critical value for t-test is plus or minus 2.045. And the calculated value of the test statistic is 2.738. So the critical value when it is 2.045 and the calculated value is 2.738, what we notice is calculated value is greater than the critical value. So we reject the null hypothesis, right? So this is how we simply do. And if you can understand this logic, it makes it a lot more easier for you to work out any numerical that you do in a z-test, any numerical that you do in t-test, any numerical that you do in ANOVA, chi-square. Now what happens in your quality control chart is it is not a horizontal normal curve, but it is a vertical normal curve which decides what is the central line, what is the limits tolerance, upper control limit and lower control limit. So it's typically again the hypothesis testing that we go about with using. So what conclusion we draw about this bulb here is there is sufficient evidence to conclude based on the sample that the average life of the light bulbs is different from 1000 hours. So again, to reiterate the steps that are involved in hypothesis testing, we formulate the null and alternate, we select an appropriate test, we choose the level of significance, we collect the data and we calculate the test statistic, we determine the probability that is associated with the test, we compare the level of significance level, we decide what is the critical value. So if our calculated value exceeds the critical value, we say the null hypothesis is rejected. If the calculated value is less than the critical value, we say the null hypothesis is accepted. So we use it for different things. It could be areas of marketing, finance, HR, or any field. Remember that research is generic. It is not domain specific. In all researches is the same process of hypothesis testing. And to summarize, hypothesis testing is a structured process that involves stating a hypothesis, choosing a significance level, selecting and calculating a test statistic, making a decision based on comparing of the test statistic to critical value and drawing a conclusion. So this process helps researchers make informed decision about population parameters based on a sample data. Once again, to tell the steps that are involved in hypothesis testing, the first step is setting up of hypothesis, where we set the null and the alternate. Null is represented with the symbol HO and alternate with H alpha or H1. The second is deciding upon the level of significance. Based on that, we decide what is the critical value. Level of significance is denoted by the symbol alpha, Greek notation, which is either 5% or 1%. That is chances of committing a type 1 error, which is rejecting a hypothesis which is true. Then we decide whether we choose the parametric test or the non-parametric test. As we have said, let's reiterate once again, if we know the parent population characteristics and on such a sample, if we apply statistical tools, it is called as a parametric test. If we are not sure about the parent population characteristics, we call it the non-parametric test. So we have to decide which test do we apply, and we go about with deciding on the critical value, and then we go about with doing the calculations. Based on the results which are generated by the calculations, we go about with trying to decide whether we accept or reject the null hypothesis and take a decision about our understanding. To reiterate again, the research had got 4 phases: observation, hypothesis, experimentation, and conclusion. So what is concluded? Somebody observes something and the cycle gets continued. So in the experimentation stage is nothing but what we do in the calculation based on whether it is parametric or non-parametric. In the hypothesis, we go about deciding the null and the alternate, and we also check whether it is a hypothesis with direction or it is without direction. In our everyday life, we go about with using this hypothesis testing in many ways there. And if we are suffering with an ailment of fever, the doctor has to be sure whether it is to do with malaria, typhoid, dengue, COVID. For that, he goes about with asking for a diagnostic test. So the test will reveal which type of fever, and based on it, the medicine is prescribed by the doctor. So the doctor also goes about with trying to check whether the fever is malaria or not. So the null hypothesis, there is no malaria. Alternate hypothesis, there is malaria, right? So based on the results, we go about with accepting or rejecting. Thank you, and watch you for the next video.